Now then, it's a thoroughly miserable day out there. So I've taken the opportunity to come in the workshop and to do some investigations. And if you notice, those of you who've been watching the channel for a while, we've got the big variac out. So we all know that that means it's part of the variable voltage DC supply. So in that case it means we're testing unknown grid inverters. So this is a Steca. I've got another one down there, and I've actually got a slave as well that works with this. And the interesting thing is, this is the mains interface, or the oscillator, or whatever you want to call it, yeah, with the LCD screen, and this is the DC input, and the slave looks exactly like this aluminium portion here. And there we go. It's a 2 kilowatt grid inverter. And look, power D rating between 80 and 130 volts. So theoretically it should start working at 80 volts. But it won't do a great deal until the voltage gets up there. So effectively below 80 volts it will switch off. There you go, maximum voltage 450 volts. And current 2 times maximum 8 amps, which shows that, and 1 times maximum 16 amps, which shows that those inputs are in parallel. So they go to the same place basically. Right, okay. Let's crack on. And as you know, the main thing here is to stick mains in the mains bit and variable DC smooth from the variac into what would be the solar input and see what happens. Now these, I've done a bit of investigation, and these are quite interesting in the way that they're laid out, and the fact that effectively on this oscillator side you've got 3 inputs and 3 control sockets. So we'll have a look at that a bit later on, but first of all I think let's put some power in it and see what happens. Perhaps need a block under here. Stick that under there. Hopefully you can see a bit better. Up we go. There we go. I've taken some screws out already. So on this side you have to remove these totally. What's going on there? And this side, they're captive. Okay, so you've got to lift those out, and then this lifts like that. And there's little strain relief there and there and there, but there's a ribbon there which goes to this interface. And also there's an LED there. It's important that you're aware of that. So let's just have a brief look in here. So there, general circuitry, and it looks like there's an interface of some form there. Okay, come on, focus. But this is the interesting bit. That's the mains input, and that is a, if you can see this socket here, there's one there, it just plugs in. So this is the output from the solar interface, and this here it should just unclick. There we go. That there is like an Ethernet cable, and it just plugs in. So you see you've got 3 and 3. So that is the main side, and let's just get this meter set on continuity. So we'll just test these fuses. Yep. Good. Okay, there's also a fuse there. That's alright. So that one goes to there and not there. But does it go to there? It does. Yeah. So all these are connected there, but not to there. There. Yeah, there. I don't know what that one is. Is it earth? Yeah, it's earth. Earth. One of the ACs and the other. But they're all connected together. But this piece here is the interesting bit, because effectively it seems like within this circuitry you've got 3 oscillators which control the slave units. So if one of these packs up, you can just effectively unplug this and just move it to another socket. So that's sort of interesting. This is a slave unit, and as you can see, it's got the same connections but just with longer leads. Now the best thing to do is just to stick some power in this and see what happens. Right, so here's the mains input, and you have to fiddle with this until you find out what's going on, but effectively put a screwdriver in there and it opens up the, if you can get it right, and it opens up the jaw and you stick the cable in. Some people would think, oh, that's just quite normal, but it's actually trying to get it to work correctly. Sometimes there's a bit of a pain in the neck. And I suppose we better attach the earth. There we go. Okay, that's that one. A bit fiddly. Not like the SMA ones are a lot nicer because it's got a quick lever arrangement. Or the ABBs and the Solar Rivers have got screw terminals. So that one's just a bit fiddly, but then, you know, you're not supposed to be doing it and undoing it all the time. So here we go, let's put some DC into there. Now, those of you who don't know about this this system that I've got, basically we're taking mains through a variac which varies the voltage, then goes through a transformer which steps the voltage up, and then goes through a rectifier with a capacitor to smooth the DC, and then comes back in here. So we've got an isolated DC supply. Yeah, and just up here somewhere I will put a link to the original video showing how this is all set out, for those of you who've not seen it before. It's a bit counterintuitive in so much as you're using power from the mains through all the variac and whatnot to feed back into the mains. You'd think that can't work, but it does. So there you go. The beauty of isolation transformers. And of course a variac is not an isolation transformer, so you need something in between the variac, which is a variable auto transformer, and the rectifier to isolate the supply. So we've got the mains in. Let's just zoom out. There we go. So let's plug things in, but first of all I've got one of those which you can see if the watt meter on this is the same as the watt meter here. So let's plug that in, and we need a bit of wood again. Hopefully we can see that. There we go. So it's drawing 2.2 watts at the moment. So the DC's there. I'm just going to plug the variac in. And I would normally plug it in there, but that watt meter doesn't allow me to. So we'll plug it in here, and the variac is turned right down. And now we just turn the variac up. Let's stick it up to about there. And nothing's happened. Whoa, come on, focus. And nothing's happening. And we've got the mains on, and we've got the DC on. And we've got the menu. Let's have a look at the menu. System off. Go down to performance status, go into status. Let's go to inverter A off, inverter B off, inverter A and B. They're both off, and the LED is being silent, as it were. And let's just check the DC voltage. Okay, DC voltage 219 volts. Okay. So when we're on about 40, there, we're about 200 volts. Okay. So, what are we going to do now? Let's try one of those different inputs. So switch everything off and try again. Okay. Everything's switched off. Plug that into there. And we know that they're all interconnected. So let's just see what happens now. Switch the AC on. Wind the DC up to about 200 volts. Aha! So we've got something happening. The LED's flashing. Now these seem to take quite a while to get themselves sorted out. Now, if we go to there, we've got system standby. Interesting. So one of these oscillators, or more than one, is just not working. Hopefully you can see that. I'll move the camera now, but the LED is still flashing. Grand. So this will be G83 compliant, G83/1, which means it takes about 3 minutes to fire up. And we should hear clickety click clickety click from the relays at some point in about 2 minutes time. And where are we? That's still showing 1.4 watts just firing itself up. And of course when with these, when we finally get no power from the panels, when it's dark, then the inverter eventually just switches itself off. Hopefully you just heard that. Okay. It's doing something, but it's not very entertaining. Okay, you can hear it's working hard. Oh, it tried and then it doesn't want to. And it's trying again. I think this oscillator is faulty as well. I think we need to look at what the DC is doing as well, so let's zoom out a bit. So as the load comes on, it pulls the DC down a bit. So let's stick the DC up a bit. It's not what you call smooth, is it? It's as if it needs at least 200 volts to keep itself, but it's shouldn't be constantly fluctuating like that. Let's turn the DC volts up a bit, which is effectively where we're trying to increase the current a bit, because the inverter is actually going, oh, there's more volts, so therefore we can draw more current. So it's sort of working. It'd be interesting to see what it's like actually on some panels. So that's oscillator 3. And oscillator 2 wasn't working at all. So let's try oscillator 1 to see what happens. I'm just coming back to the let's take that off. Let's just come back to the yeah, that's fluctuating. It's obviously got some delay to it. It should be relatively smooth. Anyway, let's try oscillator 1. And it stopped flashing. So therefore there's something wrong with that oscillator. So oscillator 3 is the only one that works in this system. Let's try the other inverter. So we've got a different inverter here. So let's just see what this does. And it's plugged into inverter or oscillator 2. There we go. Strange arrangement this. Right, mains on. Contact. DC, wind it up to about 200 odd volts. And the light is flashing. And it says system off at the moment. And if you go again, go into the menu and down to status. Just pull the camera a bit forward. You can just see there. And then into status, and it says system or per inverter. So let's go down to per inverter. It says inverter A off, and it doesn't want to do anything else at the moment. So let's just come out of there. And the light, where are we? Has stopped flashing. Okay. Let's have a look at this. Switch everything off. DC down. AC off. Pull these out. There we go. Let's have a look. Do you think these might be dirty connections? I think the best thing to do is put some switch cleaner on and give them a bit of a clean up. Right, let's try back on oscillator 2. Now we've given that a clean. I suppose we better just check that we have some continuity between the mains here, which is switched off, okay, so we got mains to there, yeah, and the neutral, yeah, so that's all okay. Right, that doesn't feel particularly like good connections. They're not what you call sort of tight on those pins. You never know, it might be something silly like that. Right, let's try again. Yep. Mains on, contact. DC on, up to 200 volts. And the light's flashing. I'll get back to you when something may or may not happen. So it's continuing to flash, and now we're on standby. Right, we're on active, and it's showing it's fluctuating a bit. Right, it may be that these take a little while just to wake up and get themselves into order. Let's just give it a bit of time, because you can see it's going from 22 watts and it creeps up. Now it's warming up. Okay, let's have a look at the watt meter on the socket. That's looking fairly stable, and that's not, but it's reasonable. Right, what are the DC volts? Let's just zoom out a bit and down a bit. There we go. I'm going to go on to DC. Okay, let's turn the DC volts up a bit. Still fluctuating a bit. I don't know, I'm going to leave this running for 5 minutes just to see if it settles down. it might be a bit sensitive to this power supply. So you see it fluctuating quite a lot. I think if we get a sunny day, I'll just plug this into a one of my arrays and just see what it does. And I suspect they haven't been used for quite a while, so they could do with warming up, as it were. Right, I shall get back to you. Okay, so there you go. It's still humming away. Investigations. It's worth messing with these things to make sure that they're working correctly. And as I said earlier on, I think this needs to actually go on an array and just see what it does. If it stabilises or if there's an inherent fault somewhere. They're not new. You know, I suspect these are 10 years old, so they're sort of old technology. But if you don't have anything else, it's better than nothing. And repair and reuse rather than buy new wherever possible. It reduces your impact. Catch up with you soon.